Okay, so today we are going to be talking about factoring special cases for quadratics. So first we're going to do a little bit of review. Make this a little bit bigger for you. So remember, factoring just means that we're rewriting an expression as the product of its factors. So it might look something like x plus 2 times x minus 3. That would have come from the polynomial or the quadratic x squared minus x minus 6. So we're just taking an expression and rewriting it as a product of two binomials typically. The greatest common factor is the thing you want to pull out the very first. So even if you can factor something without taking out the GCF, you need to take out the GCF. So looking here, as you look at the numbers, all three of these numbers, we can take out a 4. So I'm going to divide them all by 4. And in addition, you can take out an x, just one x, and take away the same amount of x's from all of them. The reason why I can't take away 3 x's is because this doesn't have 3 x's to take away, and neither does this one. So the most x's that we have is 1x. So I am going to divide by 4x, 4x to all three terms. And I will pull a 4x out in front and then divide what's left over. So the 4's here are going to cancel. X cubed divided by x is x squared. 20 divided by 4 is 5. X squared divided by x is x. Negative 12 divided by 4 is 3, and the x's cancel. And then you always have to ask yourself, can this be factored further? So since it's a trinomial, can you find the factors of 3 that subtract to give you 5? Well, there are none, so that means that this is fully factored. Then we're going to look at perfect square trinomials, and so this is one of your new factor patterns that we're exploring today. Notice that this is a perfect square, 25 and x squared. This is a perfect square. I'll teach you how to determine, does this make it a perfect square trinomial? Because just because you have perfect square bookends doesn't mean that the whole trinomial is a perfect square. And then if so, it factors into this nice little squared binomial. Notice that the 5x comes from taking the square root of 25x squared, it's 5x, and the square root of 9 is 3. And then the sign of the middle term gives us the middle sign. And then finally, we will be using a lot of foiling to multiply out something like this. So we would FOIL by first, outer, inner, and last, or it's just called a double distribution. I'm taking the x and distributing through multiplication to both things over here, and then I'm taking the 2 and distributing it through multiplication over here. So what I want you to do is stop and pause the video, and I want you to find the GCF of all 4 of these, because this should be a review for you, and then see if what is left in parentheses is factorable. And if it is, keep going. So all 4 of these you should know how to factor. Okay, so hopefully you've done these on your own and you're just checking your work. So for A, they have a GCF of 7. And the 7's going to cancel. You're going to be left with just an n squared. And then here, negative 21 divided by 7 is a negative 3. So then you want to look here to make sure that this is not factorable any further, and it's not because of the 3. The only thing you can do to a binomial is take out a greatest common factor, which we just did, or the difference of 2 squares. The other thing you can do with a binomial you're going to learn here in a minute, which is the sum and difference of 2 cubes. But this is not, if this were a 9, it would have been the difference of 2 perfect squares, and then you'd be able to factor it into that plus minus pattern that we've worked with before. But it's not, so this is the fully factored form of that expression. Then if you look at B, the 9, and the 18 all have a 9 in common, so I'm going to divide that out. They do not all have an x, so I cannot divide by an x. So the GCF here is 9. So that comes out in front. And then the 9's cancel, and I have an x squared. 9's cancel here, and I have a positive x. And then negative 18 divided by 9 is negative 2. Then look here to see if this is factorable. Are there factors of 2 that subtract to give you 1? Well, yes, there are. So are there factors of 2? And 2 is negative, so we're going to subtract the factors of 2, and we're looking for a positive 1. So I'm reading it backwards. The factors of 2 that subtract, so that's where all this came from. The middle term is plus 1, so that's why I'm looking for a middle term of plus 1. There's only one set of factors for 2, and they do subtract to give us 1. The one I'm looking for needs to be positive, so the bigger of the 2 always carries that sign, and in this case, the 1 needs to be negative to combine with the 2 to make a positive 1. So the 9 gets brought down, and then this splits into 2 parentheses. The x squared becomes x and x, and then we take directly from here and place them in the parentheses. So the minus 1 and the plus 2. And so this is now fully factored. So then let's look at C. So for C, you have a GCF of 4 for all of these, and they don't all have a variable, so I can't take an x out. So I'm going to divide this by 4 and take a 4 out in front. The 4's here cancel, and you get an x squared. 8 divided by 4 is positive 2, bring down the x, and 12 divided by 4 is a positive 3. So then you want to see if this is factorable. Are there factors of 3 that add to give you 2? Nope. There's only one set of factors for 3, and it's 1 and 3. They subtract to give you 2, but because the 3 is positive, they need to add to give you 2, and there is no such possibility. So this is actually as far as you can go, and this is considered the fully factored expression. Finally, let's look at D. So as you look at the numbers 18, 9, and 27, the biggest number you can divide them all by would be 9. So I can divide them all by 9. They do not all have a y, so I cannot take a y out in front. So then I'm left with 18 divided by 9 is 2, bring down the y squared. The 9's here cancel, bring down the y. Negative 27 divided by 9 is negative 3. So then we're looking at this trinomial to see if it factors. We're going to have to multiply the 2 times the negative 3. And so I'm going to do this kind of off to the side because I'm going to end up creating a new polynomial. And I don't want to get this part messed up. So I'm going to multiply the 2 times the negative 3, and I'm going to do that off to the side over here. So I would get a new trinomial, y squared plus y minus 6. So then I want to find the factors of 6 that subtract to give me 1, and there is a set which is 2 and 3. So 6 is negative, which is why I'm subtracting. I'm looking for my middle term coefficient of 1. 2 and 3 do indeed subtract to give me 1. The 1 I'm looking for is positive, so the bigger of the 2 carries that sign. The 2 is going to have to be negative in order for those 2 to combine to be a positive 1. So then this becomes y and y, and put the minus 2 and the plus 3 here in the parentheses. But remember, because we multiplied by 2 to get this new trinomial, we have to divide by 2 again. So we're going to divide the 2 out. And so we end up with the 2 divided by 2 is negative 1. So I get a y minus 1. And then this 2 does not divide into the 3, so it pops up in front of the y, and you get a 2y plus 3. And so this is now considered fully factored. So that's a great review of what we've done before. So let's look at something new. So let's talk about factoring a perfect square trinomial. So as you look at these 2 factor patterns right here, you're going to have to learn those, but I'm not much for memorization if you understand how they're derived. So notice that if you look at the trinomial, so you're going to get something that looks like this, you'll notice first off that the bookends are perfect squares. So notice that 25 and x squared are a perfect square, and 4 is a perfect square, meaning I can take their square roots and get a nice pretty number. And so that's on both of these, whether we have pluses or minuses. Then this 2ab occurs because of the following. So if I took, and I'm going to take this one and square it, so a minus b squared really means a minus b times a minus b. And I'm going to distribute a times a, so that's a squared, a times a negative b, that's a negative ab. And then I've got a negative b times a, that's another negative ab. And then a negative b times negative b is a positive b squared. So as you can see, here's my a squared and my b squared, and that's where those come from. And then how many ab's do I have? I have 2 of them that are identical, so that's where the 2ab comes from. If I just change this to a plus, then all that's going to happen is this becomes a plus plus, and then these are both going to become pluses. And you still have 2 ABs that are identical. So this 2AB is our test for the perfect square trinomial to see if it is. And so how do you find the 2AB? Notice that the square root of a squared is a, the square root of b squared is b. And so that's where we get the a and the b from. So if I can just take the square root of my bookends, multiply them together, and then multiply it by 2 and see does it match what's here, I will have determined if I have a perfect square trinomial. So that's what I'm going to do. So I'm going to erase this. And then we're going to test this one. So again, I notice that this is a perfect square and this is a perfect square. So this is my a squared and my b squared. I need to see, does this match 2ab? So less in your head, more on paper, kill a tree. So I'm going to test it for 2ab. The more times you write it, the more likely you are to remember it. So to get my a right here, I'm going to take the square root of this. So the square root of 25x squared is 5x. To find my b, I'm going to take the square root of this. So the square root of 4 is 2. 2 times 5x is 10x, times 2 is 20x. And you want to compare this to that middle term right here. Now, at first glance, you might say, oh, those don't match. This is a positive and that's a negative. You don't pay attention to the sign. We'll force the sign to match. So just look at the absolute value. 20x and 20x matches. So as soon as it matches, you know immediately you have a perfect square trinomial that factors into this squared binomial. So you already have done the work for everything that you need. Remember, this is a and b, and this is a and b. So the 5x is going to go here. The 2x is going to go here. So I get a 5x and a 2. And then we get the sign from the middle term, a minus. So all 3 terms contribute something to this factoring. The square root of 25x squared goes here. The sign of the middle term goes in the middle. And the square root of 4 goes here. And then this is fully factored. Now, of course, if you could take out a greatest common factor before you did all of this, you should. All right, so let's look at B. So here we have B and C. I'm going to do B with you, and then I'm going to want you to stop the video and do C on your own. So again, we always look for a greatest common factor, which I don't see anything, number or variable here. I do notice that this is a perfect square, and 1 is always a perfect square. Square root of 1 is 1. So we need to test this to see, does it match 2AB? So to get A and B, we take the square root of the bookends, right? So the square root of 64x squared is 8x. Square root of 1 is 1. 2 times 8x is 16x, times 1 is 16x. And sure enough, there it matches. So because it matches, I know that its factor pattern is 1 parentheses squared. And then the 8x is going to go here. The 1 is going to go here, and then the sign from the middle term is going to go here. And so this is the factored form of that trinomial. So pause the video and I want you to do C on your own. Okay, so for C, I see I have a perfect square, so we're going to test the 28x to see if it matches 2ab. So take the square root of your bookends. So the square root of 4x squared is 2x. The square root of 49 is 7. 2 times 2x is 4x times 7 is 28x. So it matches. So immediately I know it factors into this pattern. And then the 2x goes here. And the 7 goes here. And the sign of my middle term is positive, and that goes there. Easy. Then let's review the difference of two squares. You've already done this. We've talked a lot about the difference of two squares. I'll do one with you and have you do the other three on your own. So somewhat similar to a perfect square trinomial, but only because you see perfect squares here and here, but you don't have a trinomial, you have a binomial. So there's only 3 types of binomials we can factor, really 4 types, and this is one of them. We still always want to look for a greatest common factor, but as soon as you see a binomial and you see a perfect square and a perfect square, you have to have a minus sign here. You cannot factor the sum of 2 perfect squares. It's not possible. And so as soon as you determine you have the difference of 2 squares, you have this plus minus pattern. And remember, to get a and b, you just take the square root of this and the square root of that, and your a and your b go here. So 16 and x squared are perfect squares, and so is 81, and we have a minus. So because of that, I know immediately that my factor pattern is this plus minus pattern. So to find a and b, I'm going to take the square root of my bookends. So the square root of 16x squared is 4x. And the square root of 81 is 9. That's a 9. So then you have to look, and the reason why I always put the plus first is because this won't be able to be factored as long as you took out a GCF. But it's possible that this is factorable. And in fact, 4 is a perfect square, 9 is the perfect square, and we have a minus. But the x is not a perfect square, so this cannot factor into 2 more binomials, so we're done. Whoops. Well, I'll go ahead and leave it that way. Makes it exciting. Woo-woo. Okay, so I want you to pause the video, and I want you to do these 3 on your own. Okay, so hopefully you pause the video. 25 and x squared are perfect squares, and so is 36. So I know that this is going to factor into a plus minus pattern. Take the square root of your bookends here, so we get 25 or 5x and 5x. Square root of 36 is 6 and 6. And then this can't be factored further, and this is not the difference of 2 squares, so this is the fully factored form. Now here, I have a perfect square, and anything raised to an even power is a perfect square because it just needs to be divisible by 2. And as I said, 1 is always a perfect square. So this one factors into that plus minus pattern. And then we're going to find the square root of our bookends. So square root of 9m to the 4th is 3m squared. All we're doing is taking that index and dividing 4 by 2. And then we get a 3m squared here. Then the square root of 1 is 1. And then you need to look. This would not be factorable, but this could be. This is a perfect square. We have a minus. M squared is a perfect square, but 3 is not. If 3 had been 9, we would have been able to factor this further. And then finally so this is our final, right there. And then last but not least is this one. We have a perfect square, and 9 is a perfect square. So you would think you could factor this, but the problem is right here, the plus. You cannot factor the sum of 2 perfect squares. So because of that, it is not factorable. It is considered prime. Our last special case is the sum or difference of two cubes factor pattern. So I have a cubed plus b cubed, or a cubed minus b cubed. So remember, the cube root of a cubed is a, the cube root of b cubed is b. So all you do to get these a, b's right here is just to take the cube root of these two terms there, and you have them here. You notice you have the same sign, same sign. Then forget this, and then the way to get these trinomials are easy. You're just going to look at the binomials here. So to go from a to a squared and from b to b squared, you're just going to square this and square this, and they become your bookends. To get your middle term, you're just going to multiply a times b, and you get your middle term. Same thing down here. Take this and square it. Take this and square it. Those are your bookends. To get the middle, take these and multiply them to get ab. Now how about the signs? Notice that your signs here are the same. Same. But the signs from here to here are opposite. Opposite. And these are always positive. So you might want to add that in here, that from here to here, same signs. Add that from here to here, you have opposite signs. And then here, oh, I guess not exactly there. Let me move it over. Here, this is always positive. So I'm going to do A and B with you, and then let you do C and D on your own. So I first have to recognize whether I have perfect cubes. And so we did look at what numbers are perfect cubes in Unit 3 towards the beginning of that. So if you want to look at that, feel free. That would be helpful for you. If not, I'm going to just put the power that a number is as far as its perfect cube. I'm just going to write it down for you. So for instance, x cubed, all we need is for this exponent to be divisible by 3 for a power to be a perfect cube. So because 3 is divisible by 3, the cube root of x cubed is x. Then for the 8 can be written as 2 to the 3rd power. So when I take the cube root of 2 to the 3rd, I get 2 as well. So for this one, for my binomial, I'm going to take the cube root of x cubed, and I get x. And then the cube root of 2 cubed, and I get 2. Then from here, I'm going to do the signs at the very end. Then from here, I got to square this and square this. So I'll get x squared and 4. To get my middle term, I just multiply these together. 2 times x is 2x. Then my signs. So remember that these are going to be the same sign. So this is going to be a negative. Then these signs here are going to be opposite. So this is a positive. And then this sign is always positive. And so this is the fully factored form of that difference of 2 cubes. This can never be factored because it is not a perfect square trinomial. This does not meet the 2ab. Remember, it's going to be just ab. So this cannot be factored. There are no factors of 4 that add to give you 2. All right, so let's look at b. I'm going to move this over a little bit so that you can still see the factor pattern. So b, this is a perfect cube because, as we said before, 8 is 2 cubed. This is a perfect cube. This is a perfect cube. And the reason why that's a perfect cube is because 27 is 3 to the 3rd. 8 is 2 to the 3rd. So I have the sum of 2 cubes. So I got a binomial and a trinomial. To get my binomial, I'm going to take the cube root of here. So the cube root of 2 cubed is 2. Because essentially, remember, I'm just taking this index and dividing it in here, and I get 2 to the 1st. Take this, I get y to the 1st. So then I've got cube root of y cubed is y. And then the cube root of 27 is 3. Now I'll do my signs last. So to get this over here, this trinomial, I'm going to square this. Well, you have to square the 2 and the y. So 2 squared is 4, y squared is y squared. So I get 4y squared. And then 3 squared will go here, which is 9. Then to get your middle, you're going to multiply these two together. 2y times 3 is 6y. Now your signs, same sign. So we've got a plus here. Opposite signs. So we've got a minus here. And then always positive. So it's always positive. And remember, you cannot factor that trinomial. There are no factors of 4 times 9 is 36 that add to give you 6. So you're done. So what I would like you to do is C and D. So stop the video. I want you to factor C and D using the factor patterns and then check your work. Okay, so we're going to go ahead and factor C, and there is a cube root on your TI calculator. So if you go to the math menu and hit math, you will see your options, and option 4 is a cube root. So you could put 343 in, and it will tell you that the cube root of 343 is 7. So 7 to the 3rd power is 343. And then for 216, if you take the cube root of that, that's going to be 6 to the 3rd power. Well, the cube root's 6, but 216 is 6 to the 3rd. All right, so I do have the difference of 2 cubes. So the cube root of this, and then the cube root of this. So I get my binomial. The cube root of 343 is 7. The cube root of x cubed is x. And the cube root of 216 is 6. So then to get this trinomial, I want to square 7 and x, and I get 49x squared. Then I want to square the 6 to get 36 here. To get my middle term, I'm going to multiply 7x times 6, and I get 42x. And now my signs. So same sign, so minus, opposite, plus, always positive, so a plus there. Then for D, so for D, this is a perfect cube and this is a perfect cube. The cube root of this is 4. So 4 to the 3rd is 64. So I'm going to take the cube root of this and the cube root of this. All right, so the cube root of 64 is 4. The cube root of y cubed is y. To get your trinomial, we're going to square this and square this. So 4 squared is 16. Y squared is y squared. To get your middle term, you're going to multiply these together. So you get 4y. Now our signs. Same sign, opposite, always positive. And we're done. All right, last set of problems. So for these problems, you got 4 more problems to do. These are all kinds of factoring, all mixed up. So you're going to have some that just have a GCF, some that have a GCF and something else. So you have difference of 2 squares, sum and difference of cubes, the swing, factoring, any of that. So go ahead and pause the video and complete A, B, C, and D on your own, and then restart the video to check. Okay, so the first thing I want to look for is the greatest common factor. So for the numbers 4, 20, and 12 all have a 4 in common. So I'm definitely dividing every one of these by 4. And then as you look at the variables, they all have an x in common, and the most x's they have in common is 1x. So I'm going to divide them all by an x. And then the y's. They all have a y in common, and the most y's that they have, so I can take away the same amount, is also 1y. So I'm going to pull a 4xy out in front of parentheses. The 4's cancel and the y's cancel. X squared divided by x is x. 20 divided by 4 is negative 5. The x's cancel. Y squared divided by y is y. 12 divided by 4 is 3. The x's and the y's cancel. And then this is not factorable at all. So you are finished with A. All right, let's look at B. So for B, there are no numbers that they have in common, but they all have an M, and the most M's that I can take away and take the same amount would be 1M. So I'm going to divide them all by M and pull an M out in front. So M cubed divided by M is M squared minus 9. M squared divided by M is M. These M's cancel and we have a minus 10. So then you want to look inside here, is this factorable? Well, are there any factors of 10 that subtract to give you 9? Yes, 1 and 10. So any factors of 10, it's negative. So we are going to subtract and look for the middle term of negative 9. So 1 and 10 subtract to give you 9. Your 9 is negative, so the bigger of the two is also negative, and the 1 is positive. So the M still gets brought down, but the trinomial gets split into two binomials. M squared becomes M and M, and then you put from your table the plus 1 and the minus 10 here, and you are finished. Then finally, we have C and D. All right, so as you look at C, there are no numbers that they have in common, and they do not all have an x, so I cannot take out a greatest common factor. This is not a perfect square, and neither is this, so it's not a perfect square trinomial. So my only choice is to swing multiply the 2 times the negative 5. So I'm going to multiply this times this, so I get x squared plus 11x minus 10. So now we're going to read it backwards. What factors of 10 subtract to give you 11? Well, there are factors of 10 that add to give you 11, but I don't believe there's any factors of 10 that subtract. So you really have to know whether you're adding or subtracting to get that 11. Now 1 and 10, they do add to get you 11, but we're supposed to be subtracting because 10 is negative. So that would give us 9. And then the only other choice is 2 and 5, which is 3. So this is not factorable. So our original problem, the 2x squared plus 11x minus 5, that's our answer. And since it's not factorable, it's prime. Then for D, the numbers definitely have a 2 in common. So I can divide them both by a 2. But they do not both have an x and they do not both have a y. So that 2 gets brought out in front. And the 2's here cancel and you get x to the 4th. 32 divided by 2 is negative 16. Tack on the y squared. Then look in here. This is a binomial. This is a perfect square. Perfect square, perfect square. So it's the difference of two perfect squares. So that 2 still gets brought down, but this binomial gets split into two binomials with a plus minus pattern. So for here, we're going to take the square root of x to the 4th. So remember, if I take the square root of x to the 4th, I'm dividing this by 2. So I get x squared here and x squared here. Then I'm going to take the square root of 16y squared. Square root of 16 is 4. Square root of y squared is y. Whoops, I'm going to write that in blue. 4y. And then a 4y. So this is never going to be factorable, but this could be. This is a perfect square. 4 is a perfect square, but y is not. And so it is not the difference of two perfect squares. So this is your final factoring for D. And that's it. Good luck on your homework. Give it a try. Let me know if you have any questions.